Okay, today's video is about variables. Make sure you pay very close attention to this video. Variables are very important in investigations, and a lot of scholars have issues identifying variables and telling them apart. There are different types. So make sure you take really good notes and rewind the video if you need to review something. So variables. A variable is anything in an investigation that can be changed. So there's something in an investigation that has the possibility of changing. It's a variable. It can be changed. Doesn't mean that it is changed, but it could be. Only one thing in your experiment will be changed, and we'll get to that in a second. If it could be changed, it's called a variable. Every investigation has variables: descriptive, comparative, and experimental. They're just used differently. For this video, we're going to talk about a sample experimental investigation. We are going to take water samples out of a lake, put bleach in them, and then see if the bleach kills bacteria. So I'm curious to see if bleach will kill bacteria. It's a good way to sanitize things. So we're going to take water out of a lake, put bleach in it, count the bacteria after we're done. So keep that in mind as we talk about variables. All right, first, the independent variable. This is what is changed on purpose to see what effect it has. So this is the point of your investigation. It's what you're testing to see what happens. So the independent variable is changed on purpose to see what effect it has. The independent variable is the only thing in your investigation that should change. Everything else should stay the same. It can also be called the manipulated variable. So some books or people will call this the manipulated variable. It's the same exact thing. I will call it independent because that's what I'm used to. In our investigation with the water samples, our independent variable is the amount of bleach. So you would have 3 samples, one with no bleach, one with 20 milliliters of bleach, and one with 40 milliliters of bleach. So what we're changing to see the effect is the amount of bleach, which would be called the independent variable. What we're changing to see what happens. All right, the second type of variable is the dependent variable. This is the result of the investigation, and it's what's measured at the end. So this is the point of your investigation. This is what happened. It can also be called the responding variable. It responds to the independent variable. So we change the independent variable, see what happens. This is the what happens. It's what you measure, it's the point of the investigation. So in our example, it'll be the number of bacteria in the water sample. That will be our dependent variable for this investigation. So we would count the number of bacteria at the end to see if the bleach killed them or not, to see how many was left over. Okay. The next type of variable is the constants, are the constants. And this is everything in the investigation that doesn't change. So, the only thing that should change in your investigation is the independent variable. Everything else should stay exactly the same. These can also be called controlled variables. I will call them constants because there's another word that includes control later, and I don't want you to get those confused. So constants stay the same. So in our investigation, everything except the amount of bleach should be exactly the same for every trial we do. So the water samples, we should get the water from the same lake. We should have the exact same amount of water. So if we have 1 liter of water in one sample, we should have 1 liter of water in another sample. The container, we should keep the water in the same type of container. We should have everything in glass or everything in plastic, whatever you decide. So if we have a 1 liter glass jar for one sample, you should have a 1 liter glass jar for the other sample. The temperature. You want to keep the temperature the same. So don't have 1 jar in a hot room and 1 jar in a cold room. Also the light. You want to make sure the light for our water samples is the same. It would be bad to have the light in different places. So if you have one sample in a window, you need to have all the other samples in that same window. We keep constants the same so that we know the result of our experiment is because of our independent variable. If we have the water at different temperatures, the bacteria could have changed because of the temperature and not because of the bleach. So everything else except your independent variable has to stay exactly the same, and that's called a constant. And lastly, a control group. This is why I call constants and not controlled variables, because I don't want you to confuse it with the control group. So, a control group is a trial of the investigation that doesn't receive the independent variable. So you're not testing this trial. There's nothing changed about it. It's plain or normal. That's how I think of it. You must include a control group if you do an experimental investigation. It's required. Some comparative investigations can have a control group, but not all of them. It depends on what you're doing. So, for our investigation, it would be a water sample without bleach. The reason you have a control group is you want something that's plain without being tested to compare to. So if we looked at our number of bacteria, we don't know if the bacteria would have died anyway. So after a week or so with the bleach in the water, we don't know if it was the bleach that killed the bacteria or if they just would have died anyway. So a sample without the bleach lets us know if we didn't add the bleach, what would our base number have been? What would the number have been without adding this? So again, a control group is a trial investigation that doesn't receive the independent variable. It's plain, it's normal, you don't do anything to it, you use it to compare.